So we were discussing last time about the cumulative distribution for the random variable that we had. Remember the random variable p of x equal to, I think it was 1/6 times 5/6 raised to power x minus 1. Do you remember that random variable? So we started working on this. We defined the cumulative distribution f of x as the sum of p of x moving from 1 to x. Actually, I'm going to put k here. So which is p of 1 plus p of 2 plus p of x. And this will be, to ease this computation, I multiply f of x by 6. So actually we had that this was 1/6, 5/6, x minus 1. So 6 f of x is equals to sum of 5/6 raised to power x minus 1. So last time I think we said that this is a equals to sum of 5/6 x minus 1. Do you remember doing all of this? 1 x. And I asked you to find this one. Does anybody try it? Sum of xn n from 0. Let's say from 0 to infinity. But in order to do this, we first need to find Sn equals to sum of n equals to 0 to infinity. I'm sorry, not infinity. 0 to capital N. Has anyone tried to get this or to do something about it? I think we started this one in class. We did something, did we do something about it last time? This sum, anyway. So I'm going to write that Sn is equals to, when n equals to 0, is 1. When n equals to 1, is x. N equals to 2, x squared. I did this for n minus 1. I have the feeling that we did that for n minus 1. And if I multiply x by Sn, this will become x plus x squared plus xn plus xn minus 1 plus xn plus 1. And then we did Sn minus x Sn minus x times Sn. Remember I told you this will cancel, we will be left with 1 minus xn plus 1. I did it for n minus 1, so we were ending with n, not n plus 1. So we have Sn, here is Sn times 1 minus x equal to 1 minus xn. So Sn is 1 minus xn plus 1 divided by 1 minus x. So what we have here is the sum of x raised to power n equals to 0 to capital N is equal to 1 minus xn plus 1 divided by 1 minus x. We call this one S capital N. Now remember that capital F of x is equal to sum of, let me write n equals to 1 x 1 over 6 5 over 6 times this is the capital F of x, which is the cumulative distribution at x. So the difference between Sn and capital F of x, I want you to observe that. The difference between F of x and capital Sn is that X for us here is 5/6. X for us here is 5/6. So I'm going to replace this to be 1/6 times 6/5 times 5/6, sum of n equals to 1 to x, 5/6, n minus 1. Can you see that we have the same thing? I just adjusted it a little bit. With this adjustment, this is going to give me 1/5 for this portion of it. This will be 1/5, sum of n equals to 1 to x, 5/6 raised to power n. Do we understand why we have this new one, this new expression? Now look at this expression. Look at this expression. If we consider x here to be 5/6, x here is 5/6. Do you see this expression? Do you see the difference between this expression and the one here? Can somebody point out a difference between the two expressions? Yes, Jacob. The starting point. This one is starting with 0, and the one we have for f of x is starting with 1. So how do we resolve it? Look, we have two ways of resolving this. We can consider that the expression we have here is Sn minus 1. Look, Sn is actually equal to 1 plus sum as n equals to 1 to n xn. Do you see that? That is, the first term is when n equals to 0, and that term is 1. So Sn is this. So Sn minus 1 is equal to sum of n equals to 1 to x, I'm sorry, to n. This is capital N. These two expressions are now similar. Can we see the similarity now? So this quantity minus 1 will give us what we have here. We will say that is Sn minus 1 is equals to 1 minus xn plus 1. This is capital N divided by 1 minus x minus 1, which is 1 minus xn plus 1 minus 1 plus x over 1 minus x, which is equal to x minus this 1 is gone. So we are left with x minus x n plus 1. Is equal to x minus xn plus 1 over 1 minus x. So we can now know what this is. We now know what this should be. Yes. This one. This one. This one. This is Sn minus 1. Okay. Thank you. Yeah. Please follow with me so that we know what we are doing. We are just working out our brain with some mathematics. So then we can say, from what we have here, we can say that if I multiply this f of x by 5, I will have 5 f of x is equal to this guy. This guy is exactly this one. When 5 over x is replaced by x. 5 over x is replaced by x. So 1 minus 5 over x is 1 over here. So we are going to write here 5 over 6 minus 5 over 6 x plus 1 now divided by 1 minus 5 over 6. I'm going to erase this part. And now we are going to say this is equal to, this is 1 over 6. So we will multiply the numerator by 6. This denominator is 1 over 6. So the answer will consist of multiplying the numerator by 6. So it will be 5 minus 5 x plus 1 divided by, it would have been 6x plus 1. We can write it as 6x, which we can write again as 5 times 1 minus 5 over 6 x f of x is equal to 1 minus 5 over 6 x. This is the cumulative distribution of that random variable. You can go home and check again, check our computations, see if everything is correct. The reason why we did this was to find a median of this distribution. But I want you to observe that when we have a discrete distribution, the median may not even be one of the values of the random variable because they skip. We have 1, 2, 3, 4, 5, 6. What I mean is that we need to solve this equation for x. So to find a median, the median of a random variable this is just to encourage you to work. I mean, it's not like it looks like a lot of work, but none of this work is really above what you have been doing so far. So now we want to say that the median of x is the solution to the equation f of x equals to half. I'm going to leave this one for you to try to do. I think you can solve that. If you set this equals to half, it will be 5 over 6x equals to half. You solve using the logarithm. Let's save time with that. The median is the solution to this equation. Remember that this equation means probability that x is less than or equals to x. That is the probability that the value is less than x is half. When you get that, it gives you the median. Now let's find a mean. The mean is E of x is equal to sum of x times P of x. Look at what this will become. E of x is sum of x over 6. Remember, f of x, the probability of x was 1 over 6. That's why I'm writing x over 6 for this x. Times 5 over 6, x minus 1. X moving from not 0. X moving from 1 to infinity, covering every value. For the mean, we are thinking about all the values of x. Now we can say that this is the same as 1 over 6, sum of 1 to infinity, x, 5 over 6, x minus 1. Now let f of x be equal to sum of 1 to infinity of 5 over 6 raised to power, I'm sorry. Yes, I'm going to change it. Let me do the way we did the last time. X raised to power n. Think about this expression. Then what is f prime of x? We did this last time. What is f prime of x? What will be f? Yes. N times x, n minus 1. From 1 to infinity. Now think about the Sn we have. Think about the Sn that we have. I'm erasing mine. So I will need your help to tell me what was that Sn. Look, Sn is equal to what? The sum from 0 to n. This is what we computed. But we know the one that starts from 1, right? We did the one from 0, and we said to get the one from 1, we just subtract 1 from what we get. So can we just start with the one with 1? We had x minus xn plus 1 divided by 1 minus x. Do you see this in your note? We did it and I erased it. I did? Okay, I want to be clear here. The first Sn I had was from 0 to infinity, from 0 to n. Okay, now we don't need it from 0, it's starting from 1. And I told you that if you want to start from 1, just remove the first term, and we did Sn minus 1 to get this expression that I have here. That is when Jacob asked me, where is the minus 1 coming from? When I did our initial Sn. If this is going to be confusing, I can, is it okay? First, let me not. Do you understand why I am putting x minus xn plus 1 over 1 minus x instead of 1 minus xn plus 1 over 1 minus x? Because that one with 1 minus xn plus 1 started from 0. The one I'm writing now is slightly different because it is starting from 1. So I want you to see the difference between small f of x and capital Sn. Can somebody tell me what is the difference? Look at this one. I'm sorry for this. I want to, anyway, I will try. This is f of x. So I am talking about this. Look at this guy. And the Sn. What is the difference? Aisha, can you see any difference between the two? Between the circle up and this one down? One goes to infinity, another one stops at n, right? So for us to get f of x from Sn, what can we do? For us to get f from Sn, somebody remember what we can do? Has anyone done calculus 4? Okay, we will just take what we call the limit at infinity. You have heard about limit anyway in calculus. So we will say that f of x is equal to the limit as n tend to infinity of Sn. Can we say that? Does it make some sense to you? F of x is the limit of Sn as n tend to infinity. Does it make sense to you in your own understanding? From the knowledge you know, I'm really getting talking. From the knowledge you know from calculus, you did limit in calculus, right? No, look at f of x here. If we want n to go to infinity, our attention will be on x, right? Let me put it on. I understand better when I'm writing on the board, but I need to do this because we are recording it so that this writing should remain on the record. So look at this. The limit of x as n tend to infinity equals to what? If x is a number bigger than 1, it will be infinity. Like 3 raised to power x. The limit as x tends to infinity is infinity. Right? Okay. Now, if x is negative, there will be no limit. For example, if x is negative 2, suppose x is negative 2. If you take it raised to power 1, it will be negative 2. Raised to power 2, it will be 4. Raised to power 3, it will be negative 8. It will be doing like this. Especially when you are bigger than negative, smaller than negative 1, but smaller than negative 1, you understand it's really like big. It will be growing. But if you are between negative 1 and 0, let's take negative half. If you are between negative 1 and 0, negative half raised to power 1 is negative half. Negative half raised to power 2 is negative 1 over 4. Negative half, no, is 1 over 4. Raised to power 3 is negative 1 over 8. Do you see this? Here we are going to be going like this. Do you see what I'm trying to do? It will be doing that. This one, we are going to be going like this. Do you see what I'm doing? And it will get to 0. Even though it is doing this, it is doing and it is reducing, it will get to 0. So now we will focus on this one, 1 over 2. When the number is between 0 and 1, actually between negative 1 and 1, excluding 1 and negative 1, we will get to 0. So can we say that for here? That if I can write this limit to be not existing, this one you will learn it in calculus. If x is less than negative 1, even at negative 1, you will be having 1, negative 1, 1, negative 1, 1, negative 1. The limit does not exist even at negative 1. Now it will be 0 if negative 1 is less than x less than 1. It is 1 at 1, doesn't really, not that important. And it is infinity if x is greater than 1. It is 1 if x equals to 1. But at 1, it doesn't help when you are doing the sum. If you are doing like this type of sum, and x equals to 1, it means 1 plus 1 plus 1 plus 1 plus 1, if we go to infinity. Are we getting me here? Now look at what will happen here. Look at Sn. Look at Sn here. X equals to 1, Sn is not defined. Do you see that? This function Sn is not defined at 1. And we all see that from calculus. So when x is between 0 and 1, when x is between 0 and 1, the limit will just work on Sn plus 1. So I will say here that it is equal to x over 1 minus x. That is, this guy will go to, this guy, when capital N goes to infinity, this guy goes to 0. Because that x for us is 5 over 6. You see this 5 over 6? It's not really that one, but our goal is going to be this 5 over 6. It is between 0 and 1. It is going to go to 0. So what I want us to understand is that if we maintain our x between 0 and 1, the limit of this will be that. Let me write it better. You know, this class is kind of mathematics. It's not just like calculating, but I'm going to get to calculation, okay? But this mathematics is, when I feel like the mathematics is not too difficult, then I do it. So we are saying that if 0 is less than x less than 1, which is what we get in our probability, x is equals to the limit of Sn as n tend to infinity, which is x over minus x. Okay. Now, maybe in calculus 3, you are going to learn, no, we are going to learn later something that a theorem that I will use here. You don't really need to know the theorem. You can understand that theorem on your own. You know that the derivative of the sum is the sum of the derivative from calculus. Is that right? The derivative of the sum is the sum of the derivative. Like if I have two functions, the derivative, you know that from calculus. Okay. Now this capital Sn is the sum of some function. 1, x, x squared, x cubed. This is like addition of some function, some polynomial. Each is differentiable. So the theorem I'm giving you now is that if you have a sum or a series of functions which are continuously differentiable, then the derivative, and it is convergent, then the derivative of the limit is equal to the sum of the derivative. So we don't really need to know really all the detail about that theorem, but to be motivated, it's kind of when we do the sum to infinity, do we still get a number? You know that if I add two numbers, I get a number, right? If I do 1 plus half, I get a number. If I add 1 over 3, I get a number. But if you keep adding like this to infinity, you are not going to get a convergence. You are not going to get a number. So when we get to infinity in mathematics, we are careful. I want you to know that so that you don't feel like, I told you something which is not true. It's not all series that are convergent. A series is a sum to infinity. It's a sum of sequence. A sequence is like x, and when you keep adding terms of a sequence, you get a series, like what we get here with our Sn. So what am I trying to tell you here? That I know that f of x equals to x over 1 over x. Then I will say that f prime of x, is equal to the limit of s prime n tend to infinity. Does this make some sense to you? I'm putting the derivative of the limit is the limit of the derivative. That's actually what I'm trying to explain. This is a theorem in calculus, but you have not, most of the time you don't get there. Even those who do calculus 4 don't get there. I want you to know that that is what, as I told you, you need calculus in this class. I will just be reminding you the aspect of calculus that you need. We accept that theorem, and if we accept that theorem, that is, the derivative of the limit is the limit of the derivative. Okay? So I see f of x equals to limit of Sn, f prime of s equal to limit of f prime of s. And this will be equal to the derivative of this function, x over 1 minus x prime. Okay, here we need some work to find the derivative. You know how to do the derivative of the quotient, right? Derivative of numerator times denominator, 1 minus x, minus numerator times derivative of the denominator, divided by what? Denominator square. What I'm doing is this. uv prime, I'm sorry, u divided by v prime is u prime v minus uv prime over v squared. From, you learn this in calculus. So this is equal to x minus x plus x, 1 over 1 minus x squared. Do you remember what f of x was? We say that, remember, e of x, you can see it. I don't have it anymore. E of x was equals to the sum times p of x. X equals to 1 to infinity. And we wrote this as sum of x over 6, 5 over 6, x minus 1. And I say that and I say that 6 e of x is equal to sum of x, 5 over 6, x minus 1. From 1 to infinity. Please pay attention to what we define as f of x. F of x was 5 over 6. Can somebody look at what we had as small f of x? If what I am writing is not what you have, let me know. So I define small f of x as f of x equal to the sum from 1 to infinity of xn, right? Now, f prime of x equals to the sum from 1 to infinity and xn minus 1. Is that right? Now, that looks to be like this. It looks like this one. So f of 5 over 6 is equal to the sum from 1 to infinity and 5 over 6 n minus 1. Is that, no, this is f prime. Do we agree with what I'm writing here? F of x equals to this, f prime of x equals to that, so f prime of 5 over 6 equals to this. Is that, can we say that? So we all know what f prime of x is. This is f prime of x here. This is f prime of x here, this one. So if we put 5 over 6 here, we get f prime of so 1 minus 5 over 6 is 1 over 6. 1 over 6 square is 1 over 36. So 1 over 1 over 36 is what? What I'm saying is replace here by 5 over 6. If you replace here by 5 over 6, you will get 1 over 6. Is that right? So which is 1 over 36. And this is 1 over 36, which is equals to what? 36. So can I say this is equal to 36? So what is E of X? What will be E of S is 6. Can we see that? Huh? E of S is 6. So I'm going to erase this. And say that I hope you will be able to understand this. 6 times, this is 6 times E of X equals to 36. So E of X equals to 6. My objective is for you to see how we are manipulating this algebra, okay? So this means that the expected number of trials before you get the number 1 the first time is 6. Now can it make some sense now? The expected number of trials to get to number 1 is 6. So this is an example of expectation. There are simple ones. When I just have some finite number, I did that. So next, on Monday, we will start with measure of variation.